चलिए पैक करेगा चिल्ली मारो अब आवाज रख करो
नको खाओ 12 बजे तक भी नको खाओ
हेलो सर गुड मॉर्निंग गुड मॉर्निंग सर
शीत करता है शीत नहीं नहीं तो
देना चाहिए
सर इज बिजी Okay, good morning all of you. So if anyone have triple students, so you can leave from the meeting. There is no class today. I will send assignment notes related to yesterday what we are discussing. So only stay the easy students.
Sir, I have a doubt, sir.
Say what is your doubt?
Sir, magnetic flux की reverse లో rotation ఉంటుందా సార్ అది యాక్సిస్ ఆఫ్ రొటేషన్
లేదు లేదు రివర్స్ లో ఉండదు అది మనం ఏదైనా తీసుకోవచ్చు ఒక యాంటీ క్లాక్ వైజ్ డైరెక్షన్ ఏ రొటేషన్ తీసుకున్నా కానీ మనకి ఈఎంఎఫ్ అనేది కట్ అవుతా ఉంటుంది సో జనరలీ a generator rotate in the clockwise direction anti-clockwise direction we will consider. So అవి కాన్సెప్ట్ మీకు తర్వాత వచ్చినప్పుడు చెప్తాను బట్ జస్ట్ కాన్సెప్ట్ ఏంటంటే when conductor cuts the flux generally we are consider clockwise direction ఇక్కడ మనం తీసుకుంటాము యాక్సిస్ రొటేషన్ ఇట్ ఈస్ ఇన్ ద రివర్స్ డైరెక్షన్ సో ఈ డైరెక్షన్ బేస్ చేసుకుని కరెంట్ ఎటైనా ప్రొడ్యూస్ కావచ్చు ఇట్ మే బి క్లాక్ వైజ్ డైరెక్షన్ ఇట్ మే బి కౌంటర్ క్లాక్ వైజ్ డైరెక్షన్ but mostly we are consider clockwise direction. So there is some mistake is given in the diagram. Right. So always it is rotated in the clockwise direction. For producing the electrical energy, we are considering the clockwise direction. So ఇలా కండక్టర్ అనేది మనకు రొటేట్ అవుతూ ఉంటుంది Okay, once again, good morning to all of you. Today we discuss about the remaining topics what we are left in the previous class. So before going to that, first we go through the review and then we will continue our class. So last class we are discussed about generation of alternating current. So to produce alternating current, the requirements, a permanent magnet is required. It is having.
గుడ్ మార్నింగ్ సార్
Very good morning. So it requires a permanent magnet and a coil or a conductor. It is having the two sides. So this is we are called as a side 1. This is we are called as a side 2. Just what we are assuming, the magnetic flux is flowing from north pole to south pole. So whenever the conductor is placed in between the magnetic poles, so then whenever we are rotating It may be clockwise direction or it may be the counterclockwise direction. So whatever the direction, so it will be cuts the magnetic flux. So simply, whenever we are placing in this manner, is parallel to conductor. So that's why Rajahir Khan. So there is no class for triple students today. If anyone is there, so you can leave from the meeting. Only EC students can stay. So group lo adhe kada message pettindi. Right. So these are the requirements. First, permanent magnet, and we have a coil. So the coil, we are attaching a slip rings. So carbon brushes that we are used for collecting the electrical energy. So because it's continuously rotating the slip rings, whenever the conductor is rotating, so the brushes will be collecting the electrical energy. So one is connecting as a positive and one is collecting as a negative. So each and every half cycle or 180 degrees, the current change its direction. So for example, the current start ayindi, it will be completed 180 degrees. So just we are assuming it is a half cycle, but at the same time it is rotating again. It will be completing the 360 degrees in the reverse direction. So where even it is a clockwise direction, so half will be we are considering as a positive, half we are considering as a negative. So the magnitude of and the direction of current and voltage will be reversal at every 180 degrees. So that is we are observed here. So right, so that whenever it is flowing through the positive direction, one half cycle produces, in another half cycle a negative half cycle is produces. So within a 360 degrees. So this is a phenomena we are followed for producing of alternating current. So generally we are using the formulas. So VA is equals to Vmax into sin theta, where theta is the omega t. So omega t we are called as the angle of coil rotation, and Vmax is the maximum voltage. So that can be produced at the 90 degrees. So this is we have discussed yesterday. So similarly for the current, I is equals to Im sin theta, Im is equals to Im sin omega t. Instead of omega t, we can write as a 2 pi ft, or another alternative formula, Im is equal to Im sin 2 pi f by capital T. So another formula we are right. So this is a waveform actually generated in generator. So one positive half cycle we are getting, one negative half cycle we are getting here. So this is a concept of generator. So if you have any doubts related to that, when we are in offline, I will practically show how the AC current will be produces. If it is possible in the next class, I want to show one animation diagram, so then you can easily understand the concept. Okay. So sine wave and concept of cycle. So sine wave, so one set of half cycle, positive half cycle and negative half cycle, that is we are called as a cycle. So here we are taking a sinusoidal waveform. So there are alternative waveforms also available. So those also we are discussed in the last class. Sawtooth, triangular, pulses. So these are all the different types of concepts we are used. So one half cycle we are called as a alternation. Full half cycle, one set of half cycles we are called as a cycle. So one half cycle we are called as a alternation. So next we discuss about instantaneous values. So to understand the concept of instantaneous values, so we are taking a positive half cycle. So we are splitted into small pieces. N number of pieces we are splitted. So at any instant of that particular time period, so what is the value is offered, so that is we are called as a instantaneous value. So there are several instant values can be available. So how many pots we can divided, so that much of values can be were obtained. So in this diagram we are taking a voltage waveform. We are cutted or splitted into the 12 pots. So there are 12 instantaneous values can be obtained. So each value is different. The magnitude of each value is different. So at V1 the value is different. At V2 the value is different. So V6 is the highest value and V12 is the 0, V11 it is not similar to the V1. So each and every one having the its own values at the particular instant of time. So for example, it is a 1 second, that is the value as V1, 2 seconds V2, 3 seconds V3. So like that we are considered at an instant of time. So the instant values is based on the time only. So next waveform. Waveform is nothing but it is a graph. It is a graph of a instantaneous values of an alternating quantity plotted against the time is called the waveform. So if you are taking a time as an x-axis, magnitude of voltage or current in the y-axis. If you draw the instantaneous values, for example at the time 1, we are indicating the 1, 2, 3, 4 up to the 12. So similarly, in the negative half cycle also, whenever the time is increases to 13, 14, 15, 16, negatively it is increasing. So that is also we are considered. So this type of consideration we are followed for instantaneous values. So if you draw the all instantaneous values within a proper manner, so that is we are called as a waveform. So next important definitions, time period. So what is time period is nothing but the time taken by an alternating quantity to complete its one cycle is known as its time period. So already in the previous classes also we have discussed about that. So a set of half cycle we are called as a half cycles we are called as a cycle. So the time required to complete one cycle, that is we are called as a time period. So frequency, the number of cycles completed per second within a second. So how many cycles is completed? So that is we are called as a frequency. So it is generally denoted by means of F and it is measured in hertz. So general formula F is equal to 1 by T. Time. So time will be. So from the formula we can observe. So one cycle per a second. So then within a specific time. So that will be give the frequency value. So generally it is measured in hertz as well as radians also. So amplitude is nothing but the maximum value attained by alternating quantity during half cycle is we are called as a amplitude. Amplitude also we are called as a maximum value. Amplitude also we are called as a maximum value or peak value also. Right? So we can see here. So this is we are called as a amplitude or peak value or the maximum value. So that is we are called as a peak value. So definition, peak value ki definition. The maximum value attained by an alternating quantity during one half cycle is called a peak value. So this is we are considering as a one half cycle, positive half cycle. So which one is the highest value? So this is the highest value. So that highest value we are called as a peak value, mean value, also amplitude or maximum value. So if four terminology lo memmali edi adigina gaani, so you can answer it. So peak value, amplitude, maximum value. So these are all we are considering as a peak value. Right? So generally it is denoted by means of EM and IM. So instead of DC we are represent VM value, but in case of AC it is denoted by means of EM. So IM is common for AC and DC. Next, average value. Average value is nothing but it is an average of all instantaneous values. So here we are taking a current waveform. Instead of that you can take the voltage value also. Right? So I will take here the current as a reference. So it is split into the number of current parts, that is I1 to IN. So then what is the formula we are getting here? I average is equals to the summation of all currents to the number of parts. So that is we are considered here. So where is the I1 plus I2 plus I3 up to IN by N. So దాన్ని మనం సింపుల్ గా ఏరియా ఆఫ్ ఆల్టర్నేషన్ బై బేస్, area of alternation by base. So base is a here. This is we are called as a base. So the area is nothing but the entire area will be we are called as a area of alternation. Alternation is nothing but one half cycle we are called as a alternation. So that is a formula for average value. So for example, if you want to calculate for the voltage, then we can write as a V average or E average. Instead of I, we are replacing the E average. So E is equals to, then instead of I, we are getting as a V1, V2, V3 up to so on Vn by N. So this is also same, area of alternation by base. So this formula we can use it for average value. That is an important definition. RMS value just quite complicated to remember, but simply you remember one thing. The RMS value is depending upon the heat only. Average value simply we can take as an average, but in case of the RMS value, it is depending upon the heat. So whenever a steady current is nothing but whenever DC current is flowing through a conductor which produces a heat. ఒకవేళ మీకు ఇలా యాజ్ గా స్టేట్మెంట్ గుర్తుపెట్టుకోవడం పాసిబుల్ కాకపోతే ఇలా అయినా మీరు రాసేయచ్చు. సో whenever the steady current is flowing through a conductor which produce the heat, whenever the same amount of current of AC flowing through the conductor, if the heat is produced as the same, that is we are called as a RMS value, or it is also we are called as a effective value. Okay? So a formula generally we are using E effective or I effective is equals to root of I1 square plus I2 square plus I3 square up to IN square by N. So simple, average value ki RMS value ki it is a one difference. We are applying the square root, square at the same time root. So then we are getting as a RMS value. So these two are mostly repeated as per the examination as a definitions. So define RMS value or average value. Right. So there we have some related problems also. So those things will be discussed in the next class. Next, form factor. Form factor. So these are the simple definitions. The ratio of the root mean square value to average value. It is the average. Average of RMS value to average value. RMS value to average value. It may be for the current or it may be for the voltage also. I RMS by I average or E RMS by E average. So this is the formula we are using for form factor. So form factor is equals to I RMS by I average. So if you simplify the RMS value, so we are getting as a IM by root 2 or VM by root 2. So if you simplify the RMS equation, so whatever we have done here, so that is can be simplified as a IM by pi. So these are the two formulas. So instead of IRMS, we can write as a IM by root 2. Similarly, I average we can write as a 2IM by pi. So if you simplify that, so root pi, so pi is come to the numerator, root 2 come to the denominator. So then what we are getting here, IM into pi by 2 is a constant, it will be still remain. So then root of root 2 into IM or 2IM into root 2. So then if you are simplify, phi is a constant, IM get cancelled. So then what we are getting here, pi by 2 into root 2. So pi is a constant, it has some value, 2 into root 2. So if you are simplify, we are getting the one value. So then finally we are getting the value as 1.11. So this is we are called as a form factor. There is no units for form factor. So similarly, peak factor. Peak factor is a ratio of maximum value to RMS value. So form factor, RMS value to average value. Peak factor, it is a ratio of maximum value to RMS value. So peak factor is defined as the ratio of maximum value to RMS value of an alternating quantity. So similarly, peak factor is represented with a formula as Im by IRMS or Em by ERMS. So similarly, we can write here peak factor is equals to Im by IRMS. That implies Im is a constant, so there is no changes, but RMS value is depending upon the root 2. So then we are getting the value as Im by root 2 is equals to, so what we are simply, if we are simplify, how can we get root 2 is in the denominator. So when we are change the equation, then it will be entered into the numerator. So then the value is we are getting as a root 2 into Im by Im. So denominator, numerator, Im get cancelled. So then we are getting the value as root 2. So that implies 1.4142. So that is the value we are getting as a peak factor. So form factor is a 1.11. Next peak factor is a 1.4142. So most of the cases in this chapter we are getting the problems related to the determine average value, RMS value, peak factor and form factor. So this type of problems may be asked for the examination. So but most of the cases we are expect these questions for definitions only. Right? So first average value, it is an important. Next